Okay, let's do one more of the chi-square test for homogeneity. Inspired by the Does background music influence what customers buy, which we didn't get to do. Example, that was a fun one to do in class. Stat students decided to investigate other ways to influence a person's behavior. 60 volunteers. She randomly assigned 20 volunteers to get the red survey, 20 got the blue, and 20 got the control. First 3 questions on each survey were the same, but the 4th and 5th were different. For example, the 4th question on the red survey was, when you think of the color red, what do you think about? On the blue survey, the question replaced red with blue. On the control survey, the questions were not about color at all. As a reward, the student let each volunteer choose a chocolate candy in a red wrapper or a chocolate candy in a blue wrapper. So they put this idea in the volunteer's head about color, and then they let them choose a piece of candy. What color candy did they choose? So here are the results: red, blue. So those of the 20 people that took the red or the question on the survey about red, 13 chose the red candy, 7 chose the blue candy, and so on. Do these data provide convincing evidence that the true distributions of color choice are different for the 3 types of surveys? True distributions. So we're talking about distributions. We're talking about 3 different random samples. Okay. Well, in this case, not random samples, as you'll see here in a second. So we know that this is a chi-square test for homogeneity. And I'm going to do an independence problem here in a second. You'll see the differences, but those are the keys. We're comparing distributions, and there are more than one treatments or samples. So I went ahead and did this problem in the interest of time. HO. There is no difference in the true distributions. HA, there is a difference in the distributions. Okay. Under the plan, we will construct a chi-square test for, there's that word, homogeneity. Random, the problem states that 60 volunteers were randomly assigned to one of 3 treatments. Okay, so it's not a random sample this time, it's random treatments. Or they were randomly assigned within the treatments, I should say. 10%, we haven't done one of these in a while. This is an experiment, so the 10% condition is not necessary. We had 60 volunteers, so remember that that means it's an experiment and that the 10% condition is not necessary. Okay. Large counts, so let's go ahead and I'm going to show you how to do this in the calculator. There's the expected counts, just write them all out and say that they are at least 5. So to do this, we're going to go to second matrix, and we're going to go over to edit. It is 2 rows, 3 columns. It was 13, 5, 8, 7, 15, and 12. And we're going to go to stat test. Choose chi-square test. A, B. There will be the chi-square and p-values. I'm going to go back and open up matrix B down there. And there are the expected counts. Okay? And you can just go ahead and enter them to the near side, it'll be fine. Alright, so back to the problem. So chi-squared, I went ahead and entered that value, 6.65, degrees of freedom is 2. As again, we have 2 rows, 3 columns. I subtract 1, so that's minus 1, minus 1. So I take 1 times 2, so degrees of freedom is 2. There's the p-value, and we're going to go ahead and reject. So there is convincing evidence that there is a difference in the distributions based on the color of question you're asked about in the survey, you will choose a different type of candy. Okay? All right, last question. We'll do an independence one here. Is there a relationship between gender and relative finger length? Chapter 5, we looked at the sample. 452 U.S. high school students completed a survey. The two-way table shows the gender of each student and which finger was longer on the left hand or on their left hand. Is this an observation or experiment? Okay. Well, since there are no treatments assigned, no treatments assigned, this will be an observation. And I know for a fact there'll be a question on the College Now exam. Observation versus experiment. No, treatments are assigned. Do the data provide convincing evidence of, and here we go, association. So association is going to be independence. Chi-square test of independence. The other thing, it was one sample. So those are the two things to look for. How to tell whether it's a test of independence or a test of homogeneity. Again, when you get into advanced statistics, you'll do more with the difference between the two, but the write-up is looking exactly the same. Just make sure that you identify between homogeneity and independence. So here we go. In the interest of time, I went ahead and wrote this out sloppily, sorry. HO, there is no association, remember, null hypothesis, the hypothesis of no change. So there's no association between gender and relative finger length. Okay, so looking up here, what does gender have to do with relative finger length? We're saying that there's no association. HA, we're saying there is an association. And again, in this class, we're not going to say what that association is. Some of the advanced stats classes I've taken over the last couple of years, we get into all that, and that's like way, way hard. But for the purposes of this, again, you're just saying that there is an association, if there is one. So again, if it's independence, you say association. If it's homogeneity, you're talking about the distributions. Plan. We will construct a chi-square test for independence. Is your finger length independent of your gender? Random. The problem states (452 U.S. high school students were randomly sampled (10%). There are at least 4,520 U.S. high school students large counts. These are all at least 5. Let me show you how to enter this when there's already something there, because I haven't done that yet. So second matrix, I'm going to go over to edit, and there's something already in there. And if you guys delete these out, you're going to get a big headache. So I just always type over them. That's the easiest thing to do. So just 3 by 2, okay? And you're only going to use A and B, so don't get cute and just, keep doing C and D and E and F. Don't just type over A all the time. Don't make it tough on yourself. 52 and 43. Okay? And you're going to go to stat test chi-squared. Enter A and B. Wow, look at that p-value. That is super small. Okay, so it's about 0. Chi-squared value is really, really large. Again, as your test statistic increases, your p-value decreases. So, second matrix. Hey, look, B is now 3 by 2 also. Must have just re-entered all that stuff. And there they all are. Look, they're all bigger than 5. or at least 5. So just copy them all down. Again, nearest hundredth will be fine. And back to this. So you'll fill all those in. Fill in. Okay, the due chi-squared is 29 point whatever it was. I don't even have it now. Something. Degrees of freedom is 1, and p-value is essentially 0. So conclude, since 0 is less than alpha equals 0.05, we reject HO. There is convincing evidence of an association between finger length and gender, okay, among the high school students who filled out this survey. And that's it. I will give you a couple more to try in addition to the homework that you've hopefully been working on, and that'll be it, guys. So I will talk to you soon.